Hello dear students, welcome to my 6th class on relations and functions. In this lecture video, I'll be discussing about relations and properties of relations. So first we will define what is relations. For any non-empty sets A comma B which is contained in the universe and any subset of the Cartesian product A cross B will be called as a relation from A to B. And any subset of A cross A will be called as a binary relation on the non-empty set A. So next is properties of relation. The first one is reflexive relation. A relation R on a set A is said to be reflexive if A comma A belongs to the relation R for all A belongs to the non-empty set A. So next is irreflexive relation. A relation R on a set A is said to be irreflexive if A comma A does not belong to the relation R for any A belongs to the non-empty set A. Third one is symmetric relation. A relation R on a set A is said to be symmetric if B comma A belongs to R whenever A comma B belongs to R for all A comma B belongs to the non-empty set A. So a relation which is not symmetric will be called as an asymmetric relation. For example, I'll be taking a non-empty set A here and A contains 3 entries, that is 1, 2, 3. So now I'm going to make an ordered pair to form a relation. So the first one is R1. So R1 is given by 1, 1, 2, 2, 1. And R2 is given by 1, 2, 2, 1, 1, 3. So in this one we have to identify this R1, R2 is symmetric or not. We can see that in the relation R1 it contains 1, 1, 2 and 2, 1 is so we can say that this R1 is a symmetric relation here because this 1, 2 and 2, 1 belongs to the relation R. I mean it contained in the A cross A also. And in the R2 we can observe that 1, 2 and 2, 1 is there, but we have to note on 1, 3 to say R2 is a symmetric one. We must have 3, 1 also, but 3, 1 is not contained in the relation R2 here. So we can say that R2 is an asymmetric relation. Only R1 is a symmetric relation here. So this is antisymmetric relation. A relation R on a set A is said to be antisymmetric if whenever A comma B belongs to R and B comma A belongs to R, then we must have A must be equal to B. So those kind of relation will be called as an antisymmetric relations. So next is transitive relation. A relation R on a set A is said to be transitive if whenever A comma B belongs to R and B comma C belongs to R, then A comma C must belongs to R for all A comma B comma C belongs to A. This is called transitive relation. Example, I'm taking a non-empty set A which contains 4 entries 1, 2, 3, 4 and R1 is given by 1, 1, 2, 3, 3, 4, 2, 4 and R2 contains 1, 3 and 3, 2. So now we have to observe that or we have to verify that this R1, R2 is transitive or not. So in R1 we can note that 1, 1 is there. So 1, 1 is obviously it is a transitive one. So now the first one is 2, 3 and 3, 4 is there. 3, 4 is there. So obviously we must have now 2, 4. So then R1 contains 2, 4 also here. So therefore we can say that R1 is transitive. In the case of R2, we have 1, 3, 3, 2. But here no entry which contains 2, 3 or 3, 1, right? So hence we can say that it is a not transitive one. So next is equivalence relation. A relation is said to be equivalence if that R is reflexive and that R is symmetric and transitive. So to say an R is an equivalence relation, that R must satisfy all these 3 properties. The first one is reflexive property, second one is symmetric property and third one is transitive property. Example, a relation R on a set A is equal to ABC is given by the following matrix. The matrix is given like M is equal to 1, 0, 1, 0, 1, 0, 0, 0, 1. So So now we have to verify that R is an equivalence relation or not. So according to the given non-empty set A and the matrix M, I'm going to frame the relation R first. So I'll be getting the R is equal to what? A comma A comma C, B comma B, C comma C. So now we have to note that this A comma C belongs to R, but C comma A is not contained in the R. So we can say that now R is not symmetric, because to say R is symmetric, we must have A comma C as well as C comma A also. But C comma A is not contained in the relation R. So I'm saying that R is not symmetric. So since R is not symmetric, R is obviously not an equivalence relation. So this is partition of a set. So to define this partition of a set, I'll be taking a non-empty set A, and it contains some subsets like A1, A2, A3, etc., etc., AK. So now to say that this A is a partition of a set, this A must satisfy the following condition. The first condition is A is the union of A1, A2, A3, etc., etc., AK. That is, it is given by A is equal to A1 union, A2 union, A3, etc., etc., union AK. And the next condition is the two subsets of this A, I mean either A1, A2, A3, etc., etc., AK must be disjoint here. That is, AI intersection AJ must be equal to null set here for I is not equal to J. Then the set P will be equal to A1, A2, A3, etc., etc., AK will be called as an partition of E. We can see here the set A contains in the figure having 6 blocks. So this is called a partition of the given set A. Thank you.